So, I was watching back. Sorry if the lighting's kind of weird in this one. So, I was watching back the recordings that I had just done earlier today, and I talked on the flavors of the quarks and stuff, right? And then I did another talk after that one later on, and I had said the difference between the phases, the reason why atoms and just materials in general heat as they gain energy, melt, and then after they melt, they evaporate into gas. And I kind of went into the reasoning and potential logic behind that being the case, and I was kind of breaking that down. And then after I had that talk, right, I did that, and I was coming back and I'm looking through my videos now, and I like to listen back to them as I edit them. I don't really edit them. I just put like a denoising bit on there. But I like to listen back to it, one, to make sure that you can actually hear what I'm saying, and two, to just kind of, listen to what I said and kind of think on it a little bit. And, for reasons like this, because I'm listening back to this to this video, and I'm talking about like the different flavors of the neutrinos, and then I make the connection. I'm like, wait a minute, 3 flavors, 3 phases of matter. The gas is the most energetic, and when the more energy it has, the more it expands. What if the quarks are doing the same thing? What if the 3 different flavors are really just the 3 different phases of matter, but for quarks? And so, I mean, I don't know if I really have a whole lot to say about it. I mean, if you, I'm going to probably post this as a separate video on its own, but I recommend watching both of those videos to get an understanding of what I'm talking about here, because basically I think what's going on is that, we know that the majority of mass comes from really just the energy in the quarks, not necessarily the quarks themselves. Like, there's not a lot of mass in the actual quark. It's the gluons and the energy being passed within the quark. So it would make sense that a higher energy quark would have more energy, right? Obviously, our higher mass would have higher energy, would have more gluons, and if it has more gluons, it's going to have to make room for all these gluons, right? So it gets, so it would appear to be a larger particle. And I mean, I guess I am also thinking about this from the perspective of how they're demonstrated, because we showed them as being bigger sizes, but that it's not like we actually see them that way. So that could be a misconception there just based off of it. But I think it makes sense that we have 3 phases of matter, right? So, and there's 3 flavors of quarks. And I also wanted to say, maybe, there's plasma for anyone that wants to get technical out there. Maybe there is plasma, right? For the quarks, but the amount of energy and the conditions that you would need for that are insane, right? And maybe that's what it was like in the first, initial few seconds of the universe, right? Maybe there was enough pressure and energy during the initial Big Bang, that there was this quark plasma. And that's why nothing was able to form, because it was this quark plasma, right? And then after it cooled down enough, this quark plasma could turn into quarks and establish itself into actual phases of matter. And then we started to get more developments and stuff. And that's why, like I said, I'm a strong component of this as above, so below factor. And so we have phases of matter, right? Why wouldn't that phase of matter thing track down, right? I mean, to me, it stands to reason that if these things that are made up by quarks behave a certain way, that behavior has evolved from somewhere, right? And if they're made up by quarks, it would make sense that evolution, that trait, that property, that behavior has come from the quarks, because that's what the quarks do. They get a lot of energy and they become more massive. And they don't necessarily stay in that state for long periods of time, but as more energy is brought in, maybe they expand. Because, going into that video, when you have more energy available, it makes sense to, try and maximize the amount of energy you're putting out to get the most return back. And then when you have less energy, you want to kind of consolidate your resources, and so you're reduced back down to a smaller size, a more stable state. And we know that solids are the more stable state, because a majority of matter is at room temperature is solid. And so it would make sense that solid is the lowest energy state. So that's why we see all of these quarks as like just up and down quarks, because that's the solid state, the most stable state for these quarks and particles to be in. And so that's why we look around, and the only time we see these higher energy state or higher energy phases of these particles is when we make it happen and we form them in the collider, because for them, room temperature is too cold. It's too cold for them to be anything other than solid. And then, you also want to factor in that, what was I going to say? I put it on hold. But, these states of matter, it just correlates so well with what we see in the behavior of these flavors of quark. So why? I think we just cracked the code. I think that's why we have flavors. They're phases. And it's just too darn cold to see them any other way now. But that's what I was going to say. And they behave the same way, so, they're slightly different, but they have the same behavior because they're not different particles. They're the same particle, but with different energy states, right? And so, as I was saying in that thing, I said they're probably the same particle, just with different energies. And so we know that, when we heat up water, it becomes, water vapor. Maybe not the best example because it's a molecule. Let's say, I don't know. We'll just say hydrogen. I don't know. Hydrogen is a gas because it's still plenty hot for hydrogen. No worries. But when you cool it down, it becomes liquid hydrogen, right? And I don't even know if it can get cold enough for it to be solid hydrogen. But if it can, maybe I should have done. I don't even know if you can do helium. I'm not picking good options here. I don't know. Let's do aluminum. Aluminum. How about that? It's a solid because it's cold enough for it to. It's too cold for it to be a liquid or a gas, but it can be made into a liquid or a gas, and it doesn't change that it's aluminum, and a lot of its properties are the same. Its material properties change, but its interaction properties, its, electromagnetic properties, I guess, maybe chemical reactive properties, are relatively the same, even though it's in a higher energy state. And so I think that the flavors are just the phases of matter. And, when you look at it from this perspective, at least in my opinion, it seems rather obvious. And, I don't know, maybe I just don't know enough to know why it couldn't possibly be, but I think that's it. And it's kind of funny because I'm just watching my video back and I'm like, wait a minute. Wait 1 minute. So, yeah. Anyway, peace out.